Hello and welcome back. In this week's video we are going to pick off immediately where we left off with last week's video on the condition system. In the previous video I had misunderstood what the handler case macro does, so we're just going to clean that up. We're going to revisit that, then we're going to get into something called invoke-restart. I'm going to explain a little bit about what that does and how that fits into the condition system. So let's start where we failed last week. I misunderstood what I was doing with this, where I thought that I could pass in these report and interactive stuff. It's not the case. What these do is they take an error object. Because this is I believe it's a macro. I may be wrong, but it takes body and it can take n forms. So what we can do here and just clean it up like this. This is all that was necessary. We have our handlers, our file IO error and another file IO error, and they take an error object, and if we go here, message is no. Let's pass in a dedicated message here. Dedicated, but not particularly great, and we will be able to see the specific messages. So we'll force a failure, and we'll get this another file IO error with error 2. And you can see here we got error 2 printed out. Now if we set this to undefined, if we don't define that, this may work the first time and indeed the second time, but we got error 1 here now, and what this has done is it's printed out the first error and it's corrected it and given us success. So this handler case macro, unlike the restart case where we have all these restarts in the debugger where we can pick from what we want to do, this handler case gives us errors or conditions and a condition object, and we can decide what we want to do with that. And that's kind of where I was struggling last week. It's actually so much simpler than I had thought, but I had been in a bit of a panic. I wasn't at my best. My mind wasn't fully focused, so I missed the obvious solution, and it happens. You know, you're tired, you're busy, it doesn't go in, but it is really simple. We get an error object and we can do something with that. We can pass it as many forms as we want, because it's I believe it's a macro and you can pass in as many forms as you like. Now that we've corrected that, we're going to move on to the invoke-restart. And I've created a new file for this, and we're going to slowly sort of drill into this and try and understand what's going on. Now, to be super clean, I've just restarted the REPL, so we're going to have, let's make that a wee bit bigger. We've got no symbols, no functions, nothing defined in this REPL here. So we're going to start completely from scratch, and we're going to do a little bit around zero division, because if you try and divide by 0, that is an error in most programming languages. Not all, because if you divide by 0 you get infinity, and some languages are able to represent what that might mean by either the sideways 8 character or simply the word infinity. Other languages will just crap out and give you an error. It's up to whatever language, what the implementers decide to do and what is right for their language. It's a philosophical thing more than anything else. So we are going to define a condition, a divide by 0 condition, and we're going to define it just like we did last week with define condition. There we go. And it's going to be on div0 error. It takes it inherits from an error object. It has a message property, and we're going to give it an init arg of message. And it's going to have a reader function, which is also called message. And we're going to compile that into the system. You can see that that's compiled in now. So if we just do error, div 0 error message hi, there we go. We've got our div 0 error and the message is hi. So we can see that that's working now. So let's get rid of that. The next thing that we want to do is we're going to create our own division function. Let's get rid of line 8. We don't need that. And division takes an A and a B, and we're gonna have our restart case here, and restart case is going to run something and potentially throw an error. If it does, it's going to give us a list of restarts. So what we're doing here is, I've not used this before, but just let me finish this. So we're not done yet. I'm just going to pause and explain what we're doing here. So this this slash equals returns null if they are equal. So let's have a look. So if the numbers are equal, does that take multiple? Oh, apparently it does. That's interesting. Oh, all the items have to be different. So that's cool. So what we're doing here is we're going to be checking to see if these two numbers, b and 0, if they are the same. So we're basically asking, is b equal to 0? In a roundabout way here. I suppose it's because we want this to be the true branch. So if b is different to 0, we can do the division of a and b because we won't get an infinite thing. However, if b is equal to 0, we're going to call the error function with our condition, passing in the message, and we're going to be trying to divide by 0 if we've got to this point. So what we want to do then is list our potential restarts. And we're going to do that by either returning 0, returning a value that the user passes in, or recalculate using our function again. So we're going to pass in our first restart. I'm going to create a little bit of space there. And then we're going to say return value R, and that returns an R. Then we're going to say recalculate using C, and this is div fn of A and C. And that's it for our division function. I'm just going to collapse these down. Just going to put that there so we know that these are our restarts. And we're then going to have a function called handle infinity. And that's going to give us some restarts. Well, no, our handle infinity function is we're basically going to call our division function with 0 as one of the parameters. Setf result. It's going to be div fn, and it takes 1 and a 0. And we're just going to print out the value. And we're going to say we want to basically just continue. Now I think we want to use just continue because continue could be one of the built-in restarts, and we don't want to confuse the two. So this will take nothing and return nil. And I think that's it. Surely I can't. Surely there's more. Oh, I know what I've done wrong. I need to move this up inside my my let block, I think. Do I? Nope, I see what I've done wrong. There we go. I closed the parentheses in the wrong place. So we need to compile these two functions in. Excuse me while I have a drink of water. My throat's quite dry. So this is going to be used in some higher level code. So this is going to set result to 0, then set result to be the result of div fn. Why are we doing this? There's no need for this. We could set it here. I found this as a tutorial on the internet, and I've had to radically transform bits of it to make sense of it. I'll post a link to the original tutorial in the description so you can read that if you so wish. However, I did not find the tutorial itself massively helpful. The use case it made was obvious, which helped, but I've had to delete and rephrase bits of it to actually get to the meat of what's here. So you can refer to that and use that as a source if you like. It's not written in a particularly Lisp idiomatic style, which is also an issue. but I credit where credit's due. Hacking at it and getting it to play nice eventually got me understanding this. I just feel it's worth saying I couldn't use it as was. That being said, yeah, I will link it. So we've got our handle infinite function. We bind the result of calling divfn of 1 and 0 to result. We print out the result, and if we've got a restart, if we've got an error, we set up our restart to have just continue and it return nil. So I'm also going to define a bunch of functions now, and they're going to largely do the same thing, but they're going to be bound to different handlers, and they are going to invoke different restarts. So we're going to say handler bind, and this is going to div 0 error, and it's going to take a lambda function, and that will take an error, and we're just going to say we want to get the message of error, and then we want to, in our lambda function, we want to invoke a restart. And we give a symbol to the restart that we want. This is going to be return value. And that's going to be 1, 2, 3, 4. Yeah, that's where we want to be. This is going to be our handle. Let's compile it. So we want to actually call our handle infinite function. So we're going to copy this and we're going to give it a different name. I'm going to copy it again. I'm going to call it gamma. And the only thing we're going to do is we're going to change the nature of the restarts. So the first one is return value. We're then going to use recalc using. And this, we're going to get rid of the value. And this is just going to be just continue. So we're going to compile our functions up here. There we go. And undefined function divfn. I'm pretty sure I had compiled it. Apparently not. Apparently I have not compiled that, so let's recompile this. Yeah, that's better. Yeah. Okay, so everything is compiled and in the interpreter now. So we're going to call alpha down here. And basically we do our handler bind and we call our handle infinite. And it will throw an error because we try and divide by 0. So we format and print that out. So we get error can't divide by 0. Which is what we get here. Because we called alpha, yeah, we called the infinite handler, and then our div by 0 error is caught. Then we run this lambda function. We print out the error. Let's make this clear. Alpha error, beta error, and gamma error. There we go, we got an alpha error, can't divide by 0. and it invokes the restart return value 1. So when this errors, it automatically invokes a restart for us, and that restart is return value, and we pass in the value of 1. So if we change this to 2, and we run alpha again, you can see that we still can't divide by 0, but the return value that was received is 2. Now it'll be exactly the same principle with beta, but the restart that we are invoking is going to be the recalc using. So instead of a 0, this will be 2, so 1 divided by 2 should be 0.5. Or actually 1/2, because Common Lisp has ratio types, and I'll show you why. Yeah, whoops, that was my fault. There we go. So 1 divided by 3 is actually 1/3, and if we see the IEEE floating point representation, that's not quite right, because if we take this times 0. I'm not sure how many 3's that is, but you know, there you go. Oh, it is indeed smart enough to figure out that that is 1, 2, 3, 4, 5, 6, 7. 2, 3, 4, 5, 6. Oh, I happen to guess exactly right. But that's just coincidence. You know, 1 divided by 3 is 1/3, and typically in Python or JavaScript or languages like that, if you took 1 and divided it by 3 and then multiplied the result by 3, you wouldn't get 1 back because it's not a ratio. In Common Lisp you can. So when we divide 1 by 2, we get 1/2 rather than 0.5. So that's just why that's there. It's a special data type called a ratio. But this does exactly what we wanted it to do. 1 divided by 2 is 1/2, and that recalculating with that value has given us a result we would expect. So if we go to gamma, this should just continue. So if we call that, can't divide by 0, we got nil because just continue doesn't return a value, and that is it. We have these functions that we've got these handlers that will do various things, and then we've got higher level code, as they call it, and presumably here in handler bind, if you have multiple errors, you can bind these multiple errors and invoke different kinds of restarts. Or you can use handler case, where if you don't care to restart, you could call something else. It's really up to you, and that's kind of what I was wanting to cover here. I have no doubt there's going to be so much more to the condition system, but that is the basics of what I've learned so far. We have conditions, we have restarts, and we've got handlers, so we can restart, handle stuff, and have various conditions. It's definitely very powerful. I imagine there is a lot of nuance to try and use the right thing in the right place. We'll come back to this another week, I'm sure, but I have a video on macros planned for Friday, so we'll be moving on to another topic come Friday. So I hope that was interesting to you. I hope it helped. I'm particularly glad I was able to expand upon a simple thing that I had not properly understood last week because I was just tired. So we'll leave it there. Have a good week, and I will see you on Friday.